It was 1905. Einstein just finished a day of work at the patent office. He decided to take the local tramcar home. It was on these rides home where Einstein would often contemplate the mysteries of nature. It was during one of these thought experiments when he had an idea that would forever change the way we understand physics. While receding away from the clock tower, he stared at the time and imagined that the cart would suddenly recede at the speed of light. He realized that while receding, the time would appear to stand still. He also knew that back at the clock tower, time would be ticking along as usual. Time would be moving slower for Einstein. What a revolutionary thought! Einstein discovered that the faster you move through space, the slower you move through time. These thoughts were the precursor to his theory of special relativity. The conventional reasoning back then was that time is absolute. Time would be ticking along the same for everyone, no matter how far away or how fast or slow anyone is moving relative to anyone else. But what Einstein had just discovered is that time is relative to a difference in speed of different reference frames. We know the speed of light to be 186,000 miles per second. We also know that the speed of light, c, is a constant, meaning that it will always be observed to move at c no matter what speed the observer is moving. This can be demonstrated by imagining a car moving at 50 miles per hour. If a person in the back seat throws a ball towards the front of the car at 5 miles per hour, an outside observer would observe the ball moving at 55 miles per hour. Now let's start over, but instead of the passenger throwing a ball, he turns on flashlight. The car is moving at 50 miles per hour, so you might expect that the light would travel at the speed of light plus 50 miles per hour, but you'd be mistaken. The light will always travel at the speed of light, even if you were traveling extremely fast. Now let's imagine that instead of a car, the passenger is inside a spaceship that's traveling just under the speed of light. Inside the ship, there are two mirrors facing each other that are bouncing light back and forth. The passenger measures how long it takes for the light to bounce back and forth. The outside observer watches the rocket fly by and also measures the light traveling at the exact same speed. But he also sees the light travel a longer distance, because from his perspective, he has to add the forward motion of the ship to the time interval between the mirrors. He's measured a longer time interval between the mirrors than the passenger has. He's watched the light travel farther without going any faster. This effect is called time dilation. The observer has measured the passenger's time running slower relative to his own. Time dilation is a fundamental result of special relativity. This theory broke the traditional understanding of time being a constant and proved that time, in fact, is different for different observers.